What you're seeing here are Tuzo and Hasson. These are structures that originate at the boundary between the Earth's core and the lower mantle, reaching heights of up to 1,000 kilometers. Horizontally, they extend much further, several thousand kilometers. They're like two submerged continents. Tuzo is located beneath Africa, brushing up against Spain, and Hasson is beneath the Pacific to the west of Latin America. There is still a lot of uncertainty about the true nature of these colossal structures because, for obvious reasons, no one has been able to go study them directly. What we do know is that they show a reduced speed of seismic waves, which implies that they are very different from the material surrounding them. A tremendous anomaly that is still very much open to debate today, with one of the main hypotheses to explain it being that they are fragments of extraterrestrial origin, literally from another world. In addition, there is another very striking oddity. Most of the so-called hotspots on Earth, areas of the planet with high volcanic activity that form islands like the Canary Islands or Hawaii, exist thanks to these zones. Yes, some of the most famous islands in the world could have an origin related to extraterrestrial bodies. The first thing is to understand exactly what the anomalies we've detected consist of. In short, when there is an earthquake, many types of mechanical waves are produced that travel underground, and they can travel all the way through the planet to be detected and processed even on the other side of the world. There are two main types of waves, P waves and S waves. P waves can travel through liquids, while S waves cannot. That's how the existence of the Earth's liquid outer core was discovered. At the antipodes of an earthquake, there was a shadow where it was seen that P waves arrived, but S waves did not. S waves arrived, and those are the ones we're interested in for our case. They can pass through these mysterious structures, which already gives us the first piece of information. They are solid, but something strange happens. Because when we analyze the waves that have passed through Tuzo and Hasson, we see that these structures have made the waves much slower than in the rest of the mantle. That's why their technical name is LLSVP, which stands for Large Low Shear Velocity Provinces. Now you should know, the speed of S waves is governed by this formula. Don't be scared. The reduced speed that is observed implies that either this number, which represents the rigidity of the anomalies, is much lower than it should be, or this other number, the density, is much higher. And this shouldn't happen, since the Earth's lower mantle is generally quite homogeneous. It is composed of magnesium, iron, and aluminum silicates, which form minerals that couldn't exist here on the surface, but they do exist at those depths due to the high pressures. Minerals that are solid, even though they're at about 2,500 degrees, once again due to the pressure, although that doesn't stop them from flowing. Something similar happens to them as demonstrated by the pitch drop experiment, which we already saw in this video on the channel. If you give them enough time, there are some substances that, even though they seem completely rigid, end up flowing like a liquid. That's why the convection currents in the mantle that move the tectonic plates and feed volcanoes can exist. And if I mention them, it's because something fascinating happens when one of these currents encounters the provinces, the anomalies. What I'm about to explain now is a hypothesis. Remember that it's very hard to test these ideas given how unreachable the interior of the Earth is. What has been observed recently is that most of the Earth's hotspots coincide with the boundaries of Tuzo and Hasson. Why? Well, there are several hypotheses. It could be that the currents simply crash against these zones, which, being much denser, would act like colossal walls that force them to rise and concentrate in those areas. Or that Hasson and Tuzo, being hotter, heat up the magma that is touching them, and you know that the hottest stuff rises. There could also be chemical interactions between the anomalies and the mantle, which would create magmas with more buoyancy. In any case, there's always some exchange of materials, so if you've ever been on one of these hotspot islands, there's a chance you've been walking on remnants of these alien structures. But why do I say they're alien? Well, because as you've seen, there's something that doesn't belong where they are. And because of the three hypotheses considered to explain them, one of them is literally the alien hypothesis. Let's look at the candidates. The first one is the least exciting. It predicts that the provinces are simply abnormally large mantle plumes. You see, when the lower mantle interacts with its neighbor, the outer core, it heats up a lot and creates structures of very hot and viscous mantle that, because of these characteristics, have an easier time rising. These are the plumes. It's a normal process that has happened throughout Earth's history, and they're usually modest structures that are very thin and elongated upwards, given how easily they rise. According to this hypothesis, Tuzo and Hasson would simply be colossal mantle plumes. That would explain their abnormally low rigidity. The problem with this idea is that, according to the models that have been made to simulate their formation conditions, they should be elongated and thin like normal plumes, but they're actually the opposite, flattened and very thick. In other words, their shape doesn't match at all what they should look like if they were mantle plumes. The second hypothesis has more support. The provinces would be the reheated remains of ancient oceanic tectonic plates that, after sliding under each other and sinking toward the bottom of the earth like stones in an ocean, a process called subduction, would reach the boundary between the mantle and the core. Many of these pieces would accumulate there, and little by little they would get very hot. But since they are made of basalt, a composition very different from the mantle, they wouldn't actually melt, but they would be much less viscous, so they would rise and cause a seismic anomaly. Something that supports this hypothesis is the existence of the so-called ultra-low velocity zones, small pools of now molten material in the lower part of the mantle, which are located right at the base of Tuzo and Hasson. As we've seen before, almost nothing in the mantle has the chemical composition needed to melt, so these small pools could be those basalts from the sunken tectonic plates with especially high concentrations of minerals that can actually melt. And the rest, with a composition not as extreme but close, Tuzo and Hasson. However, this hypothesis also has its problems. The thing is, the anomalies are very well defined. If they were subducted basalts, the mantle should have blurred them more after years of convective currents. Also, it seems that they are older than the very existence of this formation process, so it's time to talk about extraterrestrial worlds. It's theorized that 4.5 billion years ago, an ancient planet about the size of Mars, which had the bad luck of sharing an orbit with our planet, got too close and ended up colliding with the proto-Earth. It was called Cella, and although it's best known because debris from its cataclysmic impact is the leading hypothesis for the origin of the Moon, today we have to focus on the other remains, the ones that didn't go into space. According to models that have simulated this impact, the energy released would have been enough to open a huge scar on Earth, but not big enough to expose the mantle to the vacuum of space. At that moment, parts of Cella's own mantle, which had a radically different composition from Earth's, entered through that breach and sank into the mantle, becoming trapped there forever, but keeping their original composition and identity. I find it incredible to think that beneath our feet lie the intact extraterrestrial remains of an ancient planet that existed at the dawn of the solar system. The remnants of a cataclysmic event of dimensions we can't even begin to imagine, the vestiges of the mother of our moon. Or in other words, are pieces of the moon here on Earth. Hopefully over the years we can find the true hypothesis.